All right, so here we've got another example. We're going to do basically the same sort of thing. Looking at, well, what's our degree, what's our domain, all that good stuff. So we're going to look at this and say, okay, well, if I multiplied this out, I would get x cubed. This term part would give me an x squared. This is just going to give me an x. I think we've seen this one or something similar before, right? So we've got a degree here. If we multiply all these out, we're going to get degree 6. And our domain, of course, will be all real numbers. So since this is degree 6 and it's not been reflected, like our highest power term, our leading term would be x to the 6th, and then we'd have some lower order stuff. So we know, roughly speaking, we're going to be looking like that as far as long run behavior goes. So we can say, and it's not been reflected, as x goes to negative infinity, y goes to positive infinity, and as x goes to positive infinity, y goes to positive infinity, right? Now, thankfully, again, since this is in factored form, we know our zeros, right? We can say, okay, x plus 5 is going to give us a 0 of x equals negative 5, multiplicity 3. Then we've got x plus 1. So that's going to give us a 0 of negative 1 with a multiplicity of 2. And then we've got x minus 4. So that gives us a 0 of x equals 4. And that has plain old multiplicity of 1. So we've got negative 5. We've got negative 1. We've got 4. Okay, so we've marked these on our plot, and we know our long-run behavior, both ends are going up, right? So that helps us a little bit with our multiplicity. Let's do turning points, though. We would have a max turning points of 5, but how many do we actually have? We won't know till we sketch it out in more detail. So our negative 5, we know that's an odd multiplicity. So it is going to pass through the x-axis there, but we're going to have a concavity change, if I can draw it, right, this way. There we go. At negative 1, it's an even multiplicity, so we know it's going to not pass through the x-axis. It's just going to bounce. So we've got this. And at 4, it's got an odd multiplicity. It's got a multiplicity of 1. It's going to go straight through with no concavity change. So there, we've got kind of all of our pieces there. I'm just going to kind of, there. And we just need to kind of connect the dots here. Again, our vertical axis, our vertical scale here is probably not right because I haven't tried to find out what the y-axis is or anything like that, but the behavior near the roots in the long run behavior is correct. And we can tell things now like, well, how many turning points do we have? We have, let's see, we've got one that's going to happen here somewhere around negative 3, one that's definitely right at negative 1, and one that's going to happen somewhere 1, 2, somewhere around there. So we know we have 3 turning points. Now, of course, you can graph these, so I'll have to be creative on the tests to figure things out. So let's change this up. We'll put in our graph. Y equals x plus 5 to the 3rd times x plus 1 times x minus 4, and that was a plus 1 to the 2nd. There we go. All right, so you can see, again, the scale's way off on this from what we had, but behavior-wise, does it match what we had? We have a concavity change here at 5, right? We have tangent at negative 1, so we got a little dip here, and then we have a bigger dip there. So there we go. We are right on the money with this, just with our scale being off, because I didn't plug any points to try to match the scale here. Okay, so we've got another example, but we're about at the 5-minute mark, so we will pause for the next video.